Hi again, it's Carrie Lynn, and Greenbuild was amazing. I had a wonderful time and totally reinvigorated, and it was great seeing people, meeting new people, and sharing ideas and hearing about what people are doing in other parts of the country. And I would be remiss if I did not share with you all another favorite session that I went to. You should basically just listen to all my videos because I went to the most interesting sessions. Maybe a little bit biased, but one of my favorite sessions was using algae to capture carbon and nitrogen oxides, and it was co-presented by a representative from Intel and then a PhD student from Arizona State University. And basically, Intel has a competition every year called Sustainability in Action, and people from the local area there in Arizona can submit ideas about sustainability actions and things that they want to test out. And if Intel selects their submission, they will work with that basically submitter and see if, after brainstorming and looking into the idea a little bit further, if it's economically feasible and doable, then they'll try to implement it. So this is what brought these two presenters together, because the PhD student from Arizona State University, they are working on algae, and that university actually has ASCATI, which is the Arizona Center for Algae Technology and Innovation. They are really a powerhouse for helping develop the algae technology to use it as a biofuel. And actually, algae produces pigments for makeup. They make a cookie over there at Arizona State University out of the algae. I think I'm going to put that on my bucket list to go try. It's also used for biofuels, pharmaceuticals as well. And they really see algae as going to be the next green crude. And there's two methods. You've probably seen the ponds, and then also they have the bioreactors, which are the vertical kind of screens that they use to grow the algae and stress the algae. And then once the algae is stressed, basically 50% of it becomes a lipid for the biofuel. So the submission that ASU presented to Intel was to use algae to basically help them compensate for their air emissions, so the carbon dioxide and nitrogen oxides that they emit from their facility there in Arizona. So they got together, and the goal was to basically see how much algae it would take and how large the system would need to be to help capture the 20,000 tons of CO2 that's being emitted there on that Intel site. And the researchers found that the average algae yield was 0.6 grams per liter per day, which is about 25 grams per meter squared per day. So they're definitely working on increasing that yield. And they also had difficulty with nitrous oxide. It has low solubility in water. So it was very dependent on different things like contact time, the strain of the algae. And so that was one kind of obstacle that they ran into early on. And then basically they found that with that algae yield, to capture 20,000 tons of carbon dioxide, it would take 11,000 tons of algae. This is a lot of algae. So that basically equals 100, like a little bit over 100 acres would be needed to set up an algae site that would be large enough to capture the amount of carbon dioxide that Intel needed. And Intel right now currently would probably have the space, but that space is planned for, and they're planning to use it as they grow the facility. And so just basically the size requirement, as well as then the logistics and the details, such as the boilers run at 350 degrees Fahrenheit, so there's a concern of boiling the algae, as well as cleaning it. They went for the bioreactors, and so these things have to be cleaned. They have to be dumped every 14 days, and they have to be cleaned basically by hand. You can't use soap in there because you don't want to hurt the algae that would be added to it after the cleaning. And the panels have to be spaced just right, so that way you get the maximum absorption but then there also has to be like 4 inches between the panels. So it became very detailed within the logistics and kind of like a logistics nightmare almost. So they did not decide to do it, but they definitely see that there's a future with it. They just need to basically, that yield needs to increase, because at that point in time, the cleaning logistics, the spacing logistics, and then just the pure amount of space that would be needed. But it was encouraging because even the representative from Intel said, you know, it just wasn't feasible now, but he did see a future in it. And ASU is definitely working hard at helping to progress this technology. So it was very interesting. Thanks.